Okay, so let's see how we can apply in Python what we learned about covariance and correlation. Now that you know what covariance is, you can grasp the concept of a covariance matrix more easily. It is a representation of the way two or more variables relate to each other. The covariance between a variable and itself is the variance of that same variable, actually. So, along the main diagonal, you will have the variances of the variables, and the rest of the table will be filled with the covariances between them. Great. In our case, the variables are two stock prices. Therefore, we will expect a 2x2 covariance matrix with the variances of each stock along the main diagonal and the covariance between the two stocks displayed in the other two cells. In Python, there is no need to do mathematical calculations manually. The NumPy's var method calculates the variance of an object for us. We use it to calculate the variances of the stock prices of Procter & Gamble and Beiersdorf. We annualize these values right after that. At this stage, it is unnecessary to create a data frame and fill in each cell with values. The cov method, whose name comes from the term covariance, does this for us automatically. In the second cell, we annualize the result to obtain the annual covariance matrix. Let's examine this matrix cell by cell. The cell in the top left corner shows us the variance of the P&G stock. Is it so? Let's check. Yes, 100%. The cell in the bottom right corner represents the variance of the other stock we are examining, Beiersdorf. Check. The cov method is useful because it allows us to obtain the other number more easily. The remaining two cells show the same value because the covariance between P&G and Beiersdorf and the covariance between Beiersdorf and P&G is the same. Okay, very nice. Now, let's calculate the correlation with the help of the core method. Along the main diagonal, we see exactly 1. Why? Because we divide the variances of P&G and Beiersdorf by the same values. And it makes sense that the movement of a stock is perfectly correlated with itself, right? Here's the correlation formula. The product of the standard deviation of x and the standard deviation of x is the variance of x. Remember that. As was the case with the covariance matrix, the other two cells in the correlation table contain the same number. They tell us the stock returns of the two companies are weakly correlated. And be very careful here. This is not the correlation between the price of the two equities. This distinction often creates confusion when carrying out financial analysis. Correlation between prices and correlation between returns may show different values. They usually have different implications, and it is important to respect this distinction. Briefly, the correlation between returns, which is the same as to say the correlation between the rate of returns, reflects the dependence between prices at different times and focuses on the returns of your portfolio, rather than on stock price levels. As an investor, return is what you care about, not the nominal price of the stock, right? You want to know how much you will earn after investing in a certain company, not the quoted price of its shares. Finally, don't fall in the trap of annualizing the correlation table. It does not contain average daily values. It shows us the relation that exists between the two variables. So we need not multiply by 250. In this lecture, we presented a very important concept. Python can help you estimate certain measures, but it is not capable of providing perfect economic and financial rationale. It is your job to step in and interpret the numbers. I hope you had fun watching this video. See you in the next one.